phenomenally because, you know, they had like 6-week and 8-week contracts.
Yeah.
So they knew you'd have to pay a ton of money to get anybody to do it.
Okay, now, are you ready to go? Because I'm going to stand up here for about 30 seconds.
I just need to know how you click the slides. How do you get from one side to the other?
Good question. Just press the arrow button right there.
Yeah, the spring is really nice. Feel that.
I know it's fun. I'm not probably been in first.
You ready? Yep. Okay. All right, everybody, we're getting ready to start here. I want to thank everybody for coming this evening. I'm sorry that Leslie could not be here. She's out of town again, so you're lucky enough to have me. Ooh-ah. We're going to have a speaker talk to us today about design and building prototypes and stuff like that, and I highly recommend Chris Baker for this. He's been with the club for many, many years, I think since about 2007, is that right? And he's created a lot of prototypes for a lot of the people here. Actually, I'm going to do this because I can't see you guys. Ah, there you are. Okay. So what happens when you get old? I personally have not had him make a prototype, but if I had a client that needed one or needed to demonstrate that whatever the device was that they were creating actually operated, I would definitely have had them contact Chris. Chris has been a mechanical engineer since 1979. He's been involved in the designing and building of a number of products or machines. He's worked in the medical device industry, thermoscan thermometers, blood and urine disease diagnostic kits. He's worked in military ordnance, that is design and building systems that load the cartridge belt for the underwing cannons in the F-14s. Pretty impressive technologies. Food products, he designed and built the packaging system for the Klondike ice cream bars. If you've ever wondered how they do that, I have. I'm going to ask Chris later about it because that's very interesting. If you don't know what a Klondike bar is, it's an ice cream patty that has chocolate all the way around it. Okay, so how do they hold it? And not get your finger in there. Anyway, then he's also worked on government projects, Star Wars. Impressive program developed by Ronald Reagan to kind of scare the Russians.
Actually met with Reagan to kick it off.
So that's very impressive technology. It was a great project. I don't know if anything ever came of Star Wars, but it certainly was something that...
Oh yeah, the railgun, that's what they use.
Railgun, there you go.
off of carriers.
So it made Russia rethink. It also made Russia come to the table. And so we were able to get to some agreements that helped both countries survive. His designs have been featured in Shark Tank, QVC, and HSN. And his company works with individuals and existing companies to design and build quality products and machinery at economical pricing. That's really what we're all about. I do the same thing. Economical pricing is critical for all of us. It's very expensive to do the jobs that we do. So his major accomplishments thus far that he purports is, it's on his website, is being involved in a project that bounced that laser laser beam off the moon in the early 1980s, and the data was utilized to calibrate GPS. Very impressive technologies. He right now, I guess you are the only person who created the direct right wafer lithography, is that correct?
We did that with Bill Livesey. He won the Nobel Prize for Physics in 1968.
That's what's being used right now to manufacture microelectronics. Impressive. Anyway, there's a lot of stuff that Chris has done. I picked out just a few things off the web on him, and I actually don't think it was on your website. I think it was actually an interview that you had done that I picked most of this information off of.
Yeah, I got it right up here.
So anyway, I'd like to introduce Chris. Chris, can you come up here? And we're going to start Chris's presentation. Real quick, I also want to let you know that AMN Healthcare allows us to use this facility. We want to thank them for supporting our club. They've done so for quite a number of years now, and we really do appreciate it. So, Chris, there you are. Does he need hookup for wire mic? No, it's good. Okay. You are up, sir.
Okay. Okay, so as you've heard, I've been involved with manufacturing and designing products now for just over 40 years. I worked for Black & Decker, I've worked for Craftsman, I've worked for Caterpillar, all the big companies. So I know how products are done, I know the financial ways behind it, I know the scheduling ways behind it. So what I'm trying to do is to kind of downsize that information and bring it to inventors that are just starting out. They just built a prototype, they just have an idea, maybe they got a patent. So I'll just go through here. This is kind of the summary of the presentation. I'll go through the idea process, go through the design process, prototype creation, and then we'll have questions at the end. This is a product that I did for myself. It's a multi-tenant vise. And really the best products are things that solve a problem. You don't want to create a problem and try and solve it. You really want to solve a problem that already exists. So I was manufacturing a part for the military that needed to be held in different orientations. So I went to all the different, Home Depots and Lowe's and all those, trying to find a clamp that could do that, and couldn't be done. So I thought, well, what if I put the part in a vise and then have the vise manipulate so that I could put it in any plane, in any space in 3D. So this is the product that I came up with. And this kind of demonstrates some of the other things too. You don't have to design your entire product. You can use existing products that's out there. You can modify them. This is a vise that I buy from a tool supply house. And all I do is modify the base and create a couple more parts. And then I've got an entirely different product, and it is patented. I patented it in 2015. Recently I've been talking to Qualcomm to use this to assemble PC boards. So now I've designed this mount for a PC board. So this is the actual CAD model. And then the nice thing about a CAD model is you can use it to create your patent drawings, because the software is able to take a photograph of the CAD model in any orientation you want, with or without as many parts as you want. It can do exploded views, all those kinds of things. So what I recommend before you look at a patent or decide if you want to patent something, What you want to do is you want to get the design down, and you want to do at least the CAD models. That way, you've already killed two birds with one stone. You won't have to come back later and create CAD model or CAD drawings. And then this goes to some of the things that you need for a patent and the patent drawings. And this is another invention. This one was from a local inventor. And this is an interesting problem solved because what was happening is he was associated with assisted living facilities. So what they were doing is, these are wet wipes in here. So they were having the wet wipes on, I think everybody's seen it looks like a Kleenex dispenser that you put on top of the toilet. Yeah. So the seniors were doing this to try and get to the wet wipe. So they were twisting their backs. So Andrew came and said, hey, is there a way that we can put the toilet paper and the wet wipe in the same device? And this is kind of modeled on the razor blades idea. You pretty much, you sell just this unit for like $5 just to get it into the home, just to get it into the hospital, and then the money is in the wipes. And he actually contracted with Tidy Wipes, which is the #1 selling wipe, and they got a contract with him.
Is that okay for everybody? Sorry. Is that good?
Is that better? Okay. Yeah, and he got a contract with them to actually use their wipes in his dispenser. So that's worked out really well for Andrew. And again, that's part of the design process. You know, we didn't try and put the container for wet wipes under the toilet paper. We actually had to take a whole different approach so that it would be aesthetically pleasing. And then this goes through and tells you about patent drawings. If you wanted to create your own, there's a number of guidelines that you have to follow. These are patent drawings that were generated from the CAD model for the Tidy Wipes dispenser. So you can really save a lot of time and money if you do it in the right steps. And of course, if you don't follow their rules, they'll reject them. So what I do a lot, I work with a lot of patent attorneys like David and Don Harms up in North County. And what they do is I will design the product for their customer, and then I just provide the patent attorney with the CAD models, and they can create the CAD drawings to whatever their specifications are. So you can save a lot of time doing that because you don't want to get your CAD drawing rejected because it wasn't close enough to the edge of the page. Yeah. And this is kind of the design process. You want to see what are the requirements. Is it going to be too difficult to manufacture? Are there too many? By too many variations, it means is there going to be too many different sizes? You hear that all the time about SKUs. And, you know, are we going to need a small, a medium, and a large to sell this thing? Or can one size fit all? You have to look at those kinds of things. A lot of people want to make, you know, all these different sizes, and you want to get it to where one size fits all if you can. And fabrication is a big one as well. And there's a number of new ways to fabricate. They have 3D printing, but you can take 3D printing much further than that. This is an example of that. What we've done is we 3D printed the original, and then you create a silicone mold around this part, and then you can pour different types of urethane into that mold. And you can adjust the durometer. You can create anything from a foam rubber pad to a motorcycle helmet, depending on how stiff and how strong you need it to be. And a typical mold for something like this is under $2,000. And the parts are more than an injection molded part would be, but you don't have to pay for the mold. And it's real easy to change your design because you just print a different 3D model and you can change your design. You can get about 25 parts out of one mold. This particular part about $30 each. And this is some of the other things that you want to consider when you're designing things. And then you want to discuss with the designer, whoever you pick, have you done this before? Can you show me something that's close to what I'm trying to do? And I think that one of the best things to do with myself or any design house is to ask for referrals. Who have you worked with? Can I call them? Can I get what you did for them? And you also want to set up milestones. Typically, there will be a design consultation, and then there'll be a CAD model presentation, and then there'll be a prototype quote, and then there'll be a limited production quote. So what you want to do is you want to set up a milestone to where you pay for the design process. If you like that, now you can pay for the CAD models. If you like that, now you can pay for the prototype. Because if you go into a company and they tell you, yeah, we can do that, $50,000, they don't even know what it is. How do they know they can do it for $50,000? So what they do typically is they quote high to make sure they're not going to lose money. And as a consumer, you don't want it quoted high. So if you do a little due diligence, it'll really help you a lot. And then these are some of the things that you need to consider to keep your costs down. You don't want to do some unique and special process that nobody's ever heard of, and that you'd have to invent a machine that could do it. And you want to stay away from difficult to use and procure materials. One of the things I see a lot is people want to use titanium and people want to use Inconel. Those are very difficult materials to machine, so that would raise your cost by quite a bit. And then you don't want to over tolerance things. A lot of people think that you're going to put a plus or minus 2 thousandths on everything. A milling machine can hold about plus or minus 5 thousandths. If you have a more precise part than that, you're going to have a ground, you're going to have an EDM, and those prices are going to escalate. Then you want to look at the molding and tooling costs. This is one that a lot of people, they get the wrong impression about going overseas. The difference between manufacturing the injection molded part in the United States and doing it in China is the way that they amortize the tooling costs. In China, the same company that makes the parts makes the tool. So they can amortize it. They can sell you the tool for $15,000, but require a 50,000 part run. So what they do is they amortize the cost of the tool over that run. In the United States, the tooling shop is a different entity than the molding shop. So what they do is they have to charge enough to pay for the tool because they're buying it outside. And Chinese plastic is not cheaper than American plastic. Pretty much it's all comes from DuPont. Everybody pays the same amount of money. And you have to watch you want to watch the level of regrind. Regrind means it's been used before, it's recycled. And so the biggest problem with regrind is you can't clean it. So you have impurities, you have too much moisture, so it makes a very weak part. It looks the same, but it's very weak. That's what we're saying here. You don't want to make your part out of yields and scrap. And to the average consumer, you don't know. Looks like a part. Okay, this is kind of a design process. This is one of my customers. He's a mechanic for the LA Fire Department. Works on helicopters. So of course he's from the military helicopter repair. So he came up with this idea here. And the idea here is there's some rivets inside the fuselage of the helicopter that you can't get to with either a straight rivet setter or what they call an alligator rivet setter. So he wanted one where the head could swivel at 22-degree increments. So he made a nice drawing, and he made a wood prototype. And of course, a wood prototype won't set a rivet. But what he didn't see is there's no mechanical advantage in this design. That's because this distance from here to here is the same as this distance from here to here. So if you want 300 pounds here, you're going to need 300 pounds here. And that's really hard to do. So I redesigned it. And you can see the distance from here to here is about 1/5 the distance from here to here. So now you've got a 5-to-1 mechanical advantage. So this is the part that I designed. I built this in my shop, and this is now a Makita tool. So those are the kind of things that a product development company should be able to point out, should be able to find. You don't want just somebody that can make a pretty box. You want somebody that knows something about the mechanics. And then this shows how we developed the Tiny Mate Trio. We had the drawings, and this is the 3D CAD model, and then this is the prototype. And I have 3D printing capabilities. I made this in my shop. Okay, now we're talking more about the prototype creation and how you would do that. And as far as I'm concerned, I can take a rough idea, a sketch, a drawing, a prototype, whatever, pretty much whatever you have. And then we just sit down and decide, what's good about it, what don't you like about it, what do you like about it. A lot of times you can get some ideas from existing products. I did one that was a pot scrubber for print, and we couldn't figure out what kind of handle should we have. So I said, well, go down to Walmart and look through the irons. Give me the handle that you like. So he bought a $20 iron over to my place, and we put that handle on the front. So you don't always have to come up with, lock, stock, and barrel. And what they've done now is they have a new process that's called point cloud scanning. So you can take an object and you can scan it and automatically build a CAD model from it. I had one customer that wanted to make a soap dispenser for little kids. So we were trying to figure out what do we want it to look like. So we went and got a teddy bear. We scanned the teddy bear and turned it into a 3D model, and that's his dispenser. And then this is some of the things you want to look at when through the different stages of development. And this is where you want to do your milestones with your project development company. Because you have your project planning, and you have the concept, and you have either the schematics or the prototype documentation, and then you can actually build a unit, and then you can talk about how we're going to source it, what are the production numbers. And I see that a lot of inventors are working from the estimated retail price backwards. And I've never seen a company do that. I worked for Black & Decker. I did one of their power drills. So they gave me the specifications. They gave me, we want to fit in this part of the market. And they said, okay, so let's design it to these specifications. Let's build it for the lowest cost possible. And then we'll take our costs, we'll add in whatever profit margin we need, and we need to convince the buying public that it's a $69 drill. You don't go backwards. I have a lot of customers that come to me and say, well, I can't build this thing if I can't sell it for $20. What does that mean? And a lot of times I talk to the people and I say, what can you buy in Walmart for $20? What are you talking about? And then you also have to consider the quantity of scale. If you're going to just build a few of them, it's going to cost you a lot of money because you're going to have to do 3D printing rather than injection molded tooling. But what you want is what they call a loss leader. You want just 20, 25 of these products, and you take them to potential investors, you take them to potential marketing sites, those kinds of things. And if you get some hits, you can finance from there, because a lot of the financial institutions that back companies will take things called letters of intent. So if you go to Home Depot and you can get a letter of intent that says, if I could sell you this thing for $15 a piece, would you buy 5,000? And that you can take that to the bank and say, I have $75,000 credit here. And of course, most banks, most financial institutions will lend on a PO, purchase order. And that's typical. The payback on that is 1.5% per month. So it's basically a credit card, 18% here. And then this again is kind of what we're talking about. You do the concept development, then you do the design, and then you Sometimes you don't need to build the whole product. There's a particular part of the product that needs to do a particular thing, and then maybe just the housing that you build around it. Like when we did the direct write lithography, we brought in the inventor of the electron column, which was a device that could fire one electron at a time out the tip. So we put that on a real crude vacuum chamber and tested it to see if it could actually write through the photoresist. So there wasn't any reason to build the big $3 million machine until we could verify that we could write on the chip. So a lot of times you can do that in your inventions too. There's usually a key aspect of it that's either going to make it or break it. So there's no sense in building the whole thing and doing all the tooling and doing all the design if that key aspect doesn't work. So that's kind of what we're saying here. You do the preliminary design and you test that key aspect, make sure that it makes sense to move forward. And then this is the prototype for the rivet setting tool I was talking about. And again, we didn't design the handle. There were already products on the market that had handles. So I just bought a pair of shears, cut the handles off, and open them up. There was no reason to redesign that because the business end was the riveting head. This is the world's first selfie stick. Remember when they had camcorders that were about yay long and you held it with your hand? You would bolt that here, and then these pieces clipped onto your belt, and then you could telescope this up and down. This kind of shows the difference between manufacturing. These are machine parts out of aluminum. So there's a lot of different ways to build a prototype. And I've worked on large systems, I've worked on small systems. This is one of 7 stations that's in Broza, Mexico right now, producing the window regulators for BMW and Audi. It's a palletized system. So what it does is you put the main housing on the pallet, and then it just goes through these different stations and that's it. And this is the concept to fill the trios, tidy mates. This is what they call a walking beam. What it does is just does this kind of thing. It presents itself to the head that will do the assembly. So again, it depends on how fast you need things, how large you need things to find the production model that'll work for you. And that's important. You don't want to design something that you can't build. So you don't want to go to an industrial engineer that's going to make a really fancy product. Because if you can't manufacture it, it doesn't matter how fancy it is. And the reverse can be true as well. I worked on the inside of these, you see these Coke machines in Burger King that can deliver 75 different flavors. What they did is we worked with a company in San Francisco that made the insides. And then we went to Pininfarina in Italy, same people that do the Ferrari, and they did the casing. So it looks like something super unbelievable, brand new, but it's not. This is a machine that I did for a company called Auto Splice, puts pins in the PC boards. I had a company that manufactured these. I built 26 of them in 18 months at $100,000 a piece. Sold them to General Motors, Macom, Delco. This all came from my shop. This is one you probably saw on QVC. It's what they call a Brenger. One half is a toilet brush, the other half is a plunger. And you've got a single handle. And she came up with this idea because I believe it was Clorox put something on their website that they were looking for smaller products because they wanted to penetrate the college dorm. So she came up with this. We had this on QVC. She sold 100,000 of them on QVC. $40 a piece in 2 days. And now it's open for questions. Anybody got any questions? Yeah.
Chris, what software do you use for your CAD work?
SolidWorks, Solid Edge, AutoCAD. Depends on the companies. Solid Edge is a kind of the baby brother of Unigraphics. Unigraphics is what they use in General Motors, Ford, those companies.
Is one easier than the other to learn?
No, Solid Edge, SolidWorks about the same. The SolidWorks came off of PTC, which was Pro-E, because Pro-E was just terrible for menu structure. They didn't have that part down. So two of the people that worked for Parametric Technology broke off and wrote Solid Edge, or SolidWorks. And all of them are based off a kernel that the college Berkeley came up with. That's what's actually running in the background. So they're real similar because they're all running off the same kernel. Other questions?
Thank you.
Well, thank you for your presentation. I was just wondering, you talked about a few different examples that were like sort of existing products, but like a toilet brush and a plunger already exist.
Right.
So I'm just trying to understand, like, so combining them is novel, or like that?
Well, the whole idea of combining them was that it would fit in the dormitory and they wouldn't have to have separate
Right.
units. That was
No,
the basic problem he was
that's kinda neat,
solving.
like,
Plus, it closes up, so you don't see the dirty toilet brush, you don't see the dirty plunger.
But I guess I'm just trying to understand the patenting process, like conceptually, like what?
That's not patent.
Oh, okay. So okay.
I would say 60% of what I do is not
Okay.
patented.
That's
All
and then-
the large systems that I showed you, they're not patented.
And then just along the same line, like you showed something else that had, like, you designed something but used the handles from an existing product.
Right.
Again, like I guess I was thinking along the lines of patenting, like in the frame, the mind, I don't know,
No, when you're patenting a unique device or service. So it doesn't matter whose handles you used, it's how you use them that it's patented.
so you can, okay, I need to try to learn more.
Yeah.
Thank you.
Because there's one company that's pretty famous. They came up with a different use for WD-40, and they patented it. Yeah. It's just because they don't use it to grease locks in your car and whatever. Yeah. They think they put it in some kind of feed, which is kind of scary.
What do they use it for? I'm sorry.
I don't know. It's a super top secret, you know. And they did that with the other one as well. The what's the one that they have on the wipes that clean your car and that kind of stuff that protect them? Yeah, that was another one that they Armor All. They repurposed that one, got a patent for that.
WD-40 is not good for lots of cars.
Yeah, it's just patented for certain applications. So if you can bring in an application that is not listed on their original patent, they'll grant a patent.
WD-40 deteriorates the glass.
Yeah, it does a lot of bad things, but nonetheless, they were able to do that.
So in that case, how do you handle the WD-40? Do you license the right to use it for that purpose, or how do you handle it?
Yeah, that's what you do. Once you get the patent, then you sell the rights off the patent. And that's another thing another good thing to bring up. I did a bra case for a local stewardess because they pack and unpack their bras all the time. So she sent a soccer ball cut in half and said, can you come up with something that would do this? So I did a multi-leaf, looked like a big compact case that you'd put them in, and then you'd close it. So she wanted to license that one. So she went to Playtex to license it with only the provisional patent. Right? And they said, we don't do that kind of stuff. We just make bras. We're not interested. But it turned out that the company is a company called RL Technologies. They make the snaps and clips and that kind of thing in a bra. So they contacted Charisse and said, let us pitch it to Playtex under our name. So they ended up they gave Charisse $100,000 for the rights to patent it because she did not have a utility patent. And you need to keep that in mind when you're talking about patents. Because most of us, we can't afford the $100,000 patent attorney. So what happens is you go to the cheapest guy you can find, and and he only does so much research because it's per hour, so forth. So a lot of times you get a very limited patent if you do that. Whereas a company like RL Technologies, Playtex, some of the larger companies, they have patent attorneys on retainer. So they got to pay them whether they do anything or not. So that type of a patent attorney can do a much more encompassing patent. So it may be when you're trying to license your product to the company will say, well, your patent doesn't cover us for what we wanted to do. So what you want to do is, as you get to the end of your 12 months, that's when you want to go after a licensor before you've actually granted the patent, because they'll pay you for the rights to patent it. And that can be substantial. And Therese's example was $100,000. Plus you got a 5% licensing deal off of that. Most of the clients that I've worked with that have really done well do what they call OEM. That's original equipment manufacturer. So like April did with her JED, she manufactures the unit, and then LMA was labeling it as their product, and they were selling it. And then she would sell the pads and the peripherals that go with the unit. So she actually manufactured it. And a lot of companies would rather do that. I'm working with Lego right now, and it looks like we're going to OEM. I have like 40 different types of Lego blocks that they don't have. And there is no Lego factory. Lego OEMs, everything they sell. There's no big factory making Legos. They buy them all from different molding houses. So they're more than happy to get on the chain. Another really good example is Borg Warner. Borg Warner makes most of the transmissions in the automotive industry. All they do is change the case. And it's a T10 for Ford, it's a turbo hydromatic for General Motors, it's a C something for Ferrari, but it's the same transmission. Because Ford, General Motors, Ferrari, they don't want to get into the transmission business. If this company's been making transmissions for 100 years, we're just going to OEM their stuff. The automotive industry is famous for that. General Motors makes about 20% of the components of a car. Yeah.
Yeah, the woman that you spoke about that got the 100K and a royalty. What's a typical royalty for?
Royalty goes in stages. It depends. The royalty is based on the company's risk that's going to give you the percentage. So if you got this brilliant idea, you maybe get 1%. If you have this brilliant idea and the CAD models and it looks like it might work, you get 1.5%. If you've got tooling and you've made a few of these things and it does work and you know it works, you can get 3. If you've got marketing and you've already sold X amount of these units, you can get 5. That's pretty much how it works.
But that's it tops out at 5?
Yeah. Yeah, I haven't seen anybody do better than 5. And that's tough. And the other problem with licensing is you're relying on the company to tell you what the production numbers are. So you don't know. They tell you, we've only built 5,000 of them. You don't know. And a lot of the licensors are putting minimum numbers on their agreements now. Your agreement does not kick in until we've passed the $200,000 threshold. And strangely enough, they never pass that threshold. Because it's like going to Vegas, you know, you're the amateur, they're the pro. So you got to be really careful when you deal with that kind of thing. Yeah, I haven't seen very many people make money off license. I've seen a lot of really good response from OEM.
In case on WD-40, could WD-40 have refused to give a license for that use?
Not if you get a patent.
That's what I say.
Not if you get a patent, because you have government rights. Because I ran into that same kind of thing. I did a antenna system for Spay Wars, which is the undersea warfare. So when they made these type of antennas, they wanted as little metal in it as possible. They just wanted a real thin skin, because evidently that does the best with waves underwater. So they came to me and they said, we need to do the plastic case, but we haven't found any kind of plastic that can take the pressure at 2,000 feet. So at that time, I was doing this kind of thing for Bell, doing motorcycle helmets. So they had a process that used a resin PX205, I think was the name of it. So I told the Spay Wars, I think Bell's resin will work, but, I don't know if it's available to you. And he says, we're the U.S. government, it's available to us. So we made 30 antenna from the PX205, and it worked. That's what they use now. Yes?
What is a plastisol, and can it be 3D printed?
I'm not familiar with plastisol, I'll tell you the truth.
What is the state of 3D printing right now? Are you seeing a lot of that in finished
3D printing is really growing.
Yeah.
I'll show you an example. You can do 3D printing in the conventional ABS and the rubber-like material that they've been using pretty much since it started, but now this is stainless steel. This is 3D printed. You can also use aluminum. You can use a lot of different elastomers. Now you can print a 3D print that's transparent. You didn't used to be able to do that because the 3D printing technology is a lamination. FDM stands for finite deposit modeling. So what's that?
Fusion.
Yeah, fusion. Yeah. So what they were doing is, they'd write a pattern, drop a 10,000s, write a pattern, drop a 10,000. So there were lines of lamination between the patterns. But now they're doing more and more of the laser sintering process. So they're able to make clear parts.
So, is it still, are you saying like a finished products 3D printed, or just?
It's still, well, the cost is prohibitive. This is $300. So 3D printing is good for a prototype or maybe a master to create a mold around. So you can do just the master itself in 3D printing, and then you can do the mold around that. You can do it with silicone. If you do it with silicone, you have two halves of the mold come together. And what degrades a mold is what they call the shut-off. That's the interference between the two halves starts to degrade, and the plastic just squirts out between the two halves. So if you do a silicone mold, you can get about 25 shots before it degrades. Or you can do it half aluminum and half silicone, which is much easier to machine than two halves, because the silicone is much more forgiving to fill in the gaps and that kind of stuff. You don't have to grind the silicone. And you can get about 250 shots out of that. So sometimes that's a good way to go.
The additive manufacturing industry is changing so rapidly that there's now a monthly additive manufacturing magazine. It's so incredible because now there are, FAA repair depots now that are actually 3D printing metal parts that can be used to replace parts that have failed in aircraft and other aerospace kind of products, and they are now testing out to be as reliable and strong as the...
Yeah, if you center it, it will be.
Right.
Yeah, because it's actually melted together. Or you can do the other one to where you introduce carbon into the 3D printed part, and then you burn the carbon out and fuse the metal
Right.
together.
Yeah.
But 3D printing is it has its own problems, because what's happened is 3D printing has become so popular that a lot of the people that are getting into engineering now are using it almost exclusively. I worked for a company up in Santa Barbara. It's Carl Storrs. And Carl Storrs invented the endoscope in 1935. So they have an R&D place in Santa Barbara, and they brought in, college kids, interns, that kind of stuff. And they're making these parts for the new product, but they're 3D printing them. And you can 3D print a part that you can't make any other way. You can't machine it, you can't mold it or anything. So I'm sitting in a meeting with these other two guys the other day, and we're trying to pick which design we want to use. So the manager says to this guy, and it's kind of a focus group. So he says, do you have any questions about this other one, Chris? And I looked at the kid and I said, how are you going to make it? And he said, I 3D printed it. I said, that's not the question. What if you need 5,000 of them? How are you going to make it? And what was really surprising is the manager came back to me after the meeting and said, don't be so hard on him. That's really the design he likes. And I said, I'm not being hard on him. What if corporate picks this design? What are you gonna tell them? You can't make it? You know, so.
There are some parts that need to be manufactured with 3D printing concepts.
Oh,
But
yeah.
then there are some
Yeah.
parts.
Well, it can save you a lot of parts because you can make one complicated 3D model that represents 4 or 5 machine parts in production. That's where it really has its use.
You could buy 5,000 3D printers and make it.
The problem that most of it's cost and time is usually the problem. Yeah, I'm working for Philips right now doing their, I'm automating their production line for catheters. So what they've done is they've made all these fixtures on their 3D printer and now I'm going through and redesigning them to make them manufacturable and then I'm building them in my shop.
Can all plastics be 3D printed like PVC?
Can what?
Can all types of plastic be 3D printed like PVC?
No, PVC gives off chloride gas when you heat it up to the temperature you'd need to 3D print it. Because it's
It can be
polyvinyl,
poisonous.
it's polyvinyl chloride. Yeah, so it gives off poisonous gas. Because you have to bring it to melting temperature to 3D print.
So if you're able
So
to
it's
do it,
typically ABS is what they use in that case.
okay, so ABS doesn't have that problem?
No. No, you typically extrude PVC, so it never has to reach annealing temperature. You can just shove it through a die. That's how they make all the hoses and tubing.
Like they make with the pipe?
Yeah, same kind of thing, yeah. I mean, you can extrude it if you just use pressure instead of heat.
Any other questions?
Chris, you have your 1 hour free consultation, but I'm curious, typically when you're working with clients, are you doing it on an hourly basis?
Yeah.
Or are you doing it on a
What I
project?
what I do is I'll give you a quote for the engineering time, and my rate is $40 an hour, which is about a third anywhere else you'll go. Because my objective is to make you a success. I've already been a success, I don't need to be a success again. So I'm just trying, I'm kind of the incubator for inventors, to kind of get you on the right track.
Thank you. So what do they have to do now before? so
Okay, oh yeah, we have,
What's the job they're going to be doing? I passed these out.
okay.
You're going to give them 15 minutes to do something and then they're
Okay.
going to get back with you.
Well, yeah, I guess what we're trying to do is based on what you've learned in the presentation and what you already knew, see if you can answer the questions that are on the slip. And don't just guess. If you don't know it, leave it blank. If you're not sure, put a question mark next to it. Because you're not going to learn anything if you just guess on everything.
So we'll give you 15 minutes on that, is that about right?
That'd be good,
Okay.
yeah. And then if you'd like that hour free consultation, you can put your name and phone number and I'll get in touch with
All right, so we'll start 15 minutes right about now.
you. Okay?
So at about 8:05.
And of course, you can pair up, you know, and compare notes with each other.
I do not. Let's see what that is.
And I can pass around this part here if you like. Would other people like to see this? Or I'll just leave it on the table.